All right, let me finish up some more questions, just making sure you're okay with the limits. Again, here's another limit as x approaches infinity. I'm using n behavior models. I want to try one more of these. So if I said I want to find the limit as x approaches positive infinity, again, this only works, n behaviors only work if you're dealing with as x approaches infinity or negative infinity. So here it's the square root of 3x squared. Down here it's an x. And so that's the limit as x approaches infinity of the square root of 3 times absolute value of x over x. Again, the square root of x squared is absolute value of x. Then I'm going to actually break this up again. I think that's easier to see. Limit as x approaches infinity of the square root of 3 over 1 times the absolute value of x over x. Limit as x approaches square root of 3 is the square root of 3. Limit as x approaches infinity of the square root, or the absolute value of x over x. Again, because both x's are positive, it reduces to 1, and so I get the square root of 3. How would that be different if I made this negative infinity? Then I would be looking at this becoming negative 1, because again, they cancel out, but if that's a positive and x is negative, if I'm going to negative infinity, that would be negative 1, so I get negative square root of 3. How would it be different if I put a 2 there? Well, if I put a 2 there, then I would just keep that constant out here, so then I'd have the square root of 3 over 2. And again, if you're going to negative infinity, that would be negative 1, and then I get negative square root of 3 over 2. So just n behavior models with that square root. Just make sure when you take the square root of x squared, you know that's absolute value of x. And then you have to think about as x gets bigger and bigger and bigger, depending on if it's negative or positive, this really cancels to 1. So if I'm going to infinity, this is positive 1. If I'm going to negative infinity, that would cancel to negative 1. All right. And then just to make sure we're okay with the sign limits, again, it's got to be going to 0. Limit as x approaches 0. I can't put a 0 in because I get sine of 0 down here. So break it up. I see that I have the sine of 2x. So what I would probably do is put the 2 with that, with the sine of 2x. I have the sine of x. I'm going to have to get an x underneath that. And then I have that 1/3. So just make sure you haven't changed anything. I still have a 2 and a sine of x in the top. In the denominator, I still have my sine of 2x, and I have my 3. All right, so what do I have to multiply by? I have to multiply this one by x over x. And when I do that, I can actually think about this whole thing, because I'm multiplying all of these things. If I multiply by x over x, I can put this x with the 2, and I can put this x with the sine of x. So some of you are multiplying like every 1 by x's. But if you can see that if I multiply by sine or by x over x, all of this is multiplication, I can put the x anywhere I want to. So this would be the limit as x approaches 0 of 2x over the sine of 2x. That's going to take care of this x and this 2 and this sine of 2x. I have the sine of x over x. That's going to take care of this and this. And then I still have my 1/3. So again, on the numerator, I still have my 2 times x times the sine of x. In the denominator, I still have my sine of 2x, and then a 3 and an x. Sine of 2x, 3 and x. As long as you're multiplying everything, that's fine. That's what you need to do. Now I see that I can evaluate the limit. This is 1. The limit of that is 1, and the limit of 1/3 is 1/3. So remember, you're not canceling this out until you evaluate the limit. And so I get an answer of 1/3. All right. Okay. Another learning target is that you can sketch a function if I give you some information, and you can write the equation. So I can give you any information about vertical or horizontal asymptotes. Either say it's vertical, or I could give you limits, like this could be the limit as x approaches infinity, or as x approaches 4 is infinity, or something to that effect. Whole, I usually would either tell you it's at this when x equals 3, or I might say at 3 comma something, -3. And then I could either tell you it's a horizontal asymptote, or I could say the limit as x approaches infinity of f of x is 1, because that's what happens for a horizontal. So any of those ways I could word that. So in this problem it says I have to have a horizontal or a vertical asymptote at 4, so let's draw that. Here's 4. Now make sure you label this. You either should have tick marks or you should say x equals 4 so that people know exactly what you're looking at. There's a hole somewhere at 3. I don't know where that's going to be at yet, so I'm going to just put a 3 there to remember there's a hole, and a horizontal asymptote at 1. And again, label that y equals 1. And draw that line. Some of you on the quiz just kind of had your line come down and it wasn't obvious that that was a horizontal asymptote. So draw in that dashed line. Now if it just said sketch it, we could sketch it from here and be done. But it says we have to write an equation. So remember, a couple things. First of all, if it's a vertical asymptote, you know that when you write your function, in the denominator there has to be an x minus 4, and in the numerator there can't be. So it doesn't cancel out. If it says there's a hole at 3, that means there's got to be an x minus 3 up here and an x minus 3 down here, so they cancel. And then it tells me there's a horizontal asymptote at y equals 1, which means the degrees have to be the same. So down here, if I FOIL this out, I'd get x squared. So I have to make sure I have a 1x squared up on the top. If the horizontal asymptote was y equals 2, then I'd have to have a 2x squared on top. So just to get an x, easiest thing, I could multiply by x times minus or plus anything. Easiest way to do is just put an x there. So I still have x squared for my leading term over x squared. That's going to give me a 1. So now we should be able to graph this. Again, that cancels out. So we're really going to graph x over x minus 4 with a hole at 3. So intercept, when I set x equal to 0, I get 0, 0. So I get 0 over negative 4, which is 0. So there's the x and the y-intercept. When I put in a 3 to figure out where the hole is, 3 over 3 minus 1, 3 over negative 1 is negative 3. So now I know the hole is at 3 comma negative 3, so I'm going to label that. And that's all I really need. I know the horizontal asymptote is here, so it's going to come down. There's the vertical asymptote. And now I know this can't go through the intercept anywhere here, so it's going to go in this direction. I also should double check that the function doesn't go through the y equals 1. So if you set this equal to 1 and say, does this function ever equal 1? Well, if you set this function equal to 1, you'd get x equals x minus 4, and no, that's never going to happen. Because if I subtract x, I get 0 equals negative 4. So once they tell you have to come up with the equation, there's the original equation then. Make sure you realize then you have to graph it according to your equation. Because if you would have put here instead of x, if you would have written that as x minus 7, you would get a different picture than what I've got. So make sure your graph goes with the function you have. Okay, and then the other piece of infinity is making sure you can prove end behavior models. So if you have the limit, or if you have, they want you to find if f of x is 3x squared plus 2x minus 1, and they want you to prove that g of x equals 3x squared is an end behavior, and let's even say you want to find that it's a, let's do a right end. It's a right end behavior model. Well, to prove this is an end behavior model of that, I have to look at the limit as x approaches infinity, because it's right end, so I'm going to go to positive infinity, of f of x over g of x. Now, you cannot use end behaviors to prove end behaviors, so what we need to do is we need to split it up and say we're going to look at 3x squared over 3x squared, and then 2x over 3x squared, and then minus 1 over 3x squared. We're splitting that up into 3 different pieces. Then I need to simplify each piece. So I get 1 here. Here I'm going to get 2 over 3x. And here I'm going to get nothing, negative 1 over 3x squared. Nothing simplifies. Now when I take the limit of each of those, I'm going to get 1. This is going to go to 0. This is going to go to 0. And so my limit is 1. And if the limit as x approaches infinity of that equals 1, then you can say it's an end behavior. because the limit equals 1. Okay, so that's how you prove something or show something's an end behavior.